Okay, so welcome back. Yeah, so this problem is an N-ary tree level order traversal. They go 4 to 9. It's a medium difficulty problem. Has nearly 500 likes and less than 50 likes. So I think it's a quite popular problem. Yeah, so given an N-ary tree, return the level order traversal of its nodes values. So okay, that's kind of self-explanatory, I guess. So N-ary tree input serialization is represented in the level of the traversal, which each group of children is separated by a null value. Okay, so input root and the children are 3 to 5, because there's a null value here, which means now we're gonna have a children, and then null, we're gonna have children now, so 5, 6, 5, 6, cool. So for this example, we're gonna have to traverse from 1, and then have 3 to 4, and then 5, 6. Hence, the answer is 1, 3 to 4, 5, 6. You know, it is a list of lists. Yeah. So another example, you can read this if you want. I'm just gonna go straight into what the output would look like. So we traverse the first level, 1, and then 2, 5, 4, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12, 13, 14. So yeah, I think it's kind of a self-explanatory. When we look at the problem here, it says level order traversal, which means that this is gonna be a breadth first search, so BFS. Yeah, and for BFS, what do we use? We use a queue. Yeah, so cool. Let's just start coding, I guess. So we wanna, yeah, so BFS, yeah, basic BFS problem. Cool. So we wanna check if the roots exist. So we wanna check if the tree is empty first. So if not root, so I think this is a correct Python syntax. We wanna return an empty array. I don't know how to spell. Return an empty array. Then we want to initialize a queue. Queue is equal to an empty array. No semicolons. And we want to have an output array, which is gonna be the result array, like here. So we're gonna have that, and then we want to return output. Cool. And since the root is not empty, we can add something to the queue. So root dot queue, then append root. Then we want to while root is not equal to dot length. No, actually we can do while root. So while root is not empty, so this is a Python syntax for that. While true, which means root has a value in it. While true, we can. So for N-ary trees, we have to get the current level and then traverse the trees, and then exit the loop inside that queue loop. Inside that no, actually this should be queue. Sorry. Yeah, inside that queue loop, and then loop again per level. So we want to get the length of the queue first. So this is just gonna make more sense when I actually code it. Length is equal to queue. No, it's Python. Oh, yeah, forgetting. Length of queue, and then we want to do for I in range queue. So we want to iterate. We want to iterate the current level. So we want to node get the first element in the queue, which is queue.pop of index 0. So this is gonna get pop the first element in the queue. And then, so we want a subarray. It's an empty array. So a subarray would be the values per level. In this case, there are 3 subarrays here. So we want to append output.append subarray when we finish this for loop. Yeah, so for each node, so for each level, we want to subarray, then append node that value. So we want to append the values for each level. So 3 to 4, we want to append 3 to 4. and then we want to 5, 6. Then we want to get the children of those nodes. So q that append root dot children. Actually no. So we want to iterate. Yeah, I forgot. Sorry. So for child in node dot children, q that append child. Yep. So we want to append all the nodes in the queue. So for 1, we're gonna be appending 3 to 4, and so on and on and on. I think we can use something like q.extend node.children. I'm not sure if this would work. I think it would work because extend is just adding all the elements in the array to the main array. So yeah, I think this is it. Let's try to run it. Oops. Syntax error. If not root, yes. I'm not sure about Python syntax, sorry. Okay, cool. Runtime 24 milliseconds. Nice. It's quite fast. Cool. Runtime 48 milliseconds. Faster than 90%, which means it's O of n. The complexity for this is O of n because you're gonna have to visit all nodes in the tree, and the memory usage would be O of n as well, I think, because you're gonna have to store all the nodes in the queue to the in the tree to the queue. So yeah, I think this is a very basic BFS problem. I'm not sure why it's a major problem. Yeah, cool. Thanks for watching.